I've never in my entire life heard a diesel respond like that.
Banks Built, protected by AMSOIL, with support from Roadster Shop and Nitto.
Got a good shot of his ass.
There's only good shots of my ass.
Ah, I know. I mean, this could go really wrong, so I'm not going to go there. We want to make some noise. That's what we want to do. We want to make this thing go bang, bang, bang.
In a good way.
In the best possible way, yeah.
Yes.
Because the other way, it's kicking rods out.
Yeah.
Making windows.
He does it for a minute, then we're done.
Yeah. So maybe we need to peel the skin off this thing.
Yeah, let's open her up and take a look. All right, guys, Gail put us to work. We have been kicking ass on this thing. We've got it all stripped down now. We've got it up on blocks. We have been putting a lot of effort into finishing all the details that we couldn't get finished in time for SEMA. And today is the day we are gonna fire this engine for the first time.
Oh, I can't wait.
Yeah, it's gonna be amazing. This thing is gonna be so loud. So what have we done, Eric, in the last couple months since we were at SEMA?
Visually, it looks pretty similar, although a lot has gone on behind the scenes, especially when it comes to wiring. There's a lot of wiring work being done, a lot of grounding, cab to frame, bed to frame, some harness work going on.
So right now you see it's before, then once it's done with the sling on, it'll look perfect and looks clean.
All right, let's check out some of Lockjaw's wiring. Probably the first place to start is the lithium-ion battery we have back here. It's 3100 CCA cold cranking amps. And we've got what amounts to is a 4-aught battery cable that we have connected to it through a 1000 amp fuse. And then we're going over to what we're calling a bus bank. We've got set up for the 12 volt from the battery, as well as a big bar for the grounds. And that's coming up with a 4-aught cable. Then we're going to a cutoff switch for the battery. Now we go up the footwell. The main part of the show is the Motec 142 ECM. We've also got Motec's PDM power distribution module. Well, it's a really cool fuse panel / relay control panel. And that is where we're taking and controlling all of our lights, our 12 volt ignition, our electric fans up front, our charger, cooler, coolant pump, 12 volt ignition for the various modules like the RideTech air suspension system, our transmission controller actuator system. Anything that requires 12 volt ignition is also coming from the PDM. So that's a really cool piece. And over on the right, we've got ATS's CAN translator module that translates the communications rather between the Allison TCM transmission controller under the floorboard. It takes care of all the communications between those two so it works seamlessly. So under the dash we've got Motec's keypad, which is right here, just temporarily mounted. This is all configurable and it's all on the CAN network along with our iDashes. We've got 4 iDashes up here along with Motec's display. So all that's on one CAN network, so they're all communicating to each other. It works great. I think that's about it.
Yeah, we had to move these connectors back here. They're a little too close to our headers.
Yeah, so once we got up on blocks and squared the cab, so you can see got up in there, crawled in there, squared it up. The big one was the Deutsch connectors. The current setup, they were sitting a little bit close to where the headers were, so we shifted those down, got away from all that heat that they're gonna see. Cut out an access hole on the firewall.
Yeah, that's a big help to get in here. We're really close to this firewall here with all of our heat exchanger pieces. So getting in the back to hook up connectors was pretty tough, but that access panel, that makes it real easy.
Exactly, and then some stuff I might have got carried away with, like the giant hole in the bumper that was
What'd you do to the bumper?
We needed ram air for when we idled this thing. So low on the list, but I just...
That one was low on the list.
It was low on the list, but I had fun with it.
What have we done in the back? Anything in the back?
In the back, so Curtis in the back has taken care of a lot of the plumbing. It was more or less unfinished. That was the big mechanical thing waiting. This is all hooked up.
Bedsides?
Yeah, bedsides are tied in. So we took the bracketry that was a little flimsy, and the bedsides were just sitting in space. So we threw a spine on that.
Yep.
Got these really locked
Looks
down.
good. We got Jeff in here. Jeff?
How's it going?
Good. You ready?
Oh, we're ready.
So now we're going to get serious. We're going to hot run this thing. Since SEMA in November, we've been fooling with this thing on and off, but mainly our military hybrid programs. What's happened on this, in the meantime, has been a blower change. So Eric, can we talk about this blower a little bit?
Absolutely.
I don't think anybody knows why we changed the blower, or even that we changed the blower.
Or what's going on here, and
Yeah.
yeah, we've added a few
And
things.
So, right after SEMA, brought the truck back, and Jeff Lee started running the engine. We had not fired it prior to SEMA, as I recall, at all. We just wanted it to be there. What happened was the intake temperature was being increased due to puffback or blowback from the blower at idle. And we were getting a large temperature increase here and running hot air back into the blower as a result. So we started talking with Whipple, and it turns out these screw blowers have a sweet spot, point where they're most efficient. Below that, there's a little blowback. Above that blower speed and mass flow, it pulls it through. So you get ambient air going into both the inlets here, feeding through our air filters and into here, and the ambient air has a little ram pressure due to the velocity of the truck. The faster you go, the better. And oh, by the way, the truck is a 66, but this is an earlier 60s vintage quad headlight setup, which is double ugly. The first time I ever did this was around 1960 on a 53 Studebaker at Bonneville. I removed the headlight on one side and fed a Rochester fuel injector on the small block Chevy I had in there.
And then we're subsequently banned from doing that?
Oh, I did a smoky unit. I didn't ask permission. I went and ran it, took top time in my class, and then in the next rule book, that was banned. Yeah. But there's no rule book here. This is all bandit. Back to the blower. We've got a current overdrive of 3.79 to 1. So the blower's turning 3.79 times crankshaft speed. If you round that off, it's a 3.8. And oh, by the way, so's the blower. It's a 3.8 liter billet Whipple screw, Gen 5. And then we designed all this inlet, and the blower drive extension is part of our air inlet. So we're now on a lower speed sweet spot blower than the prior one. And we'll be looking at the intake temperatures with this setup. Part of the changes we made was giving the boost air somewhere to go. In other words, regulating the boost pressure at idle. If the boost pressure at idle is too high, then your intake temperature is going to be higher than we want, and the engine will be less responsive as a result. Tell us about the blower air bypass.
Right, so we still wanted a way to help relieve some of that inlet air temperature. So in an effort to reduce the pressure ratio across the inlet to the outlet of the blower, we wanted some sort of blow off or bleed that would traditionally be done by a blow off. You have some sort of reference pressure, opens up the diaphragm, it bleeds off your excess pressure. But TurboSmart,
in a lot of cases, it's right back to the inlet of the blower.
Right, towards recirculating setup.
Yeah, we don't want that here.
Right, so we're essentially venting to atmosphere, and what we've got here is a TurboSmart ESG50. So it's an electronic straight gate, 50 millimeter. So it's a butterfly as opposed to a poppet valve.
Normally used for wastegating exhaust.
Right, so it's yes,
in a turbo setup.
Cast stainless can handle extreme pressure, but it was more of the timing in that TurboSmart had just released this at SEMA. It was a new product. I saw it in action, an extremely fast actuating butterfly valve. We had one sitting on Matt's desk. So this is the perfect opportunity. Let's try to test out the reaction of the electronic actuator. So this is what Eric and I came up with, in that we changed out the top plate of the intake manifold to have a 2-inch outlet at the back of the manifold here, coming out and ultimately plumbed into the straight gate itself, vented to atmosphere with a couple thermocouples for what temperatures we're reading off there.
Temperature coming out?
Yeah, directly out, and then post valve. See what we're eventually ultimately bleeding off.
Right.
And then, so the latest version is we're working through the calibration on that, starting with manually adjusting the valve with the cap gone.
Well, ultimately, the Motec will run.
Yeah. Ultimately, we'll be able to pick up on throttle position, and that as soon as idling, it'll have its percentage open, and as soon as you're on throttle, shuts it closed. You get the boost, and the throttle reacts right away.
So the bypass allows us to be add to the airflow through the blower at idle. Minimize the boost pressure, cool air in the intake side by moving more through.
Yeah.
So it diminishes that blowback issue.
Yeah, it keeps it real stable idle, stable temperatures.
Exactly.
So you can sit
exactly.
and not
of course,
heat soak.
my dream, you know, when you hear Formula One engines, especially the 20,000 RPM Cosworth back in the day, when those things accelerate, it's so fast, so quick, it sounds like somebody's ripping sheets. That's how I've always described it. It's a higher frequency, etc. I'm wondering what the hell this thing's going to sound like. In my dream, this thing is as quick as a Formula One engine, you know, that it's just there when you hit the pedal. So we're going to know that in a few minutes, I hope. There's a huge engine program coming from us. This is prototype Banks turnkey engine #1. This is it right here. This is the first of the Banks turnkey series. First thing I always do is crank for oil pressure before I fire an engine. In the engine room, we generally hand crank and move oil through an engine before it ever goes in the vehicle. This is the final priming of the engine. And to do this, in this case, we've got a little routine we do with the laptop to disable the fire up. So we've done that. You ready for this?
We're ready.
Okay, let's get into position. All right, we ready to go?
Yep.
All right. Okay, so here we go. 2, crank. And we've got about 28 pounds, roughly. And we push it again, and we are there. Once you see pressure, you've pretty well pushed most of the air out. I went about 10 seconds beyond that, just to be sure. So now we've got the fuel pump running. We're ready to fire.
Yep, and before we start, I'm just gonna add in and ask if you can press the down arrow on the left gauge so that way I can capture this data.
This one?
Yes, sir.
One press.
Yes, holding it down. 1, 2, 3, and start logging. There we go.
There we go. Okay, so we're logging all the data off the iDashes
Yes.
and all the data also off of the Motec, correct? So all the data. How many channels of data we got here? Maybe.
On the iDash, we're logging 100 channels total.
So we're logging 100 channels on this iDash right now.
That's right.
All right, here we go. Yep. All right. Good rail pressure. Engine oil pressure is about 55 pounds at idle. Idle RPM looks like about 850. Is that about 850? That's right. All right. We have a 4,000 RPM red line. I think I'll put on my cheaters for the little gauges. All right. Fuel mass is grams per stroke. Correct. And we're showing a boost pressure of 2¼ PSI at idle with that valve open. Yeah, the valve is open. I'm gonna let it get a little more oil temperature build up here before I whack it. And rail pressure is around nominally 77,000 PSI. I think I've read everything here. We don't have any ground speed. Charging the battery real well. All right. DGTs are quite uniform of about 250 degrees right now. There's no turbines in the My God. I don't know what to do with this. I got to tell you something, Matt. I couldn't go to sleep. I couldn't go to sleep tonight and dream anything better than that. I've never in my entire life heard a diesel respond like that. Engine number one.
All right.
Oh, yeah. I've never had an engine that responds like this. High compression, big block Chevy, with a blower, all of the above. This guy is the champion.
Like and subscribe to see Lockjaw smoke some tires.